Today's video we're going to be discussing Physics 252 Week 5 problem number 1. In this problem we are tasked with relating some different variables in simple harmonic motion to one another as a child bounces up and down on a diving board. So the key word here is that the diving board is moving up and down. Just because it's moving up and down, we can say that the child is oscillating on the end of the diving board. And relating this to simple harmonic motion, we can say that the amplitude here, this 1.6, is going to be the top of the wave. So we could say, oh, this is the top, it's going back down, and it dips down below another 0.6 meters, goes back up, and so forth, with this line being the equilibrium point. So, okay, now we know that it is simple harmonic motion. Well, we can take some of the equations that we were given in lecture this week in our first video about oscillations, and we can use these variables, or these equations, to solve for what we're asked to solve for here, which is the maximum speed, maximum acceleration. So just getting into the problem, we're given the period and we're given the amplitude. So since we're given the period, we can go ahead and start by plugging into this equation here, and we're given this as our natural frequency here. So from here we can solve for Vmax, which is going to be our maximum velocity or maximum speed, and just plugging in our given and then what we just calculated for, we're left with 2.52 meters per second. And then from our maximum acceleration here, all it is just our omega squared and our amplitude, and we're left with 10.53 meters per second squared. And so our question is, does the child have to hold on the diving board? So the answer is yes, and the reason we know this is because our acceleration is greater than the magnitude of the force due to gravity. So you can kind of think of it as the child is getting extended upwards on the diving board like they are now. If the force due to gravity was strong enough to keep them at an equilibrium point, then they would just be able to sit. And granted, it would be weird, but you could sit on this and have the acceleration keep you on the diving board. But the issue is our acceleration here is what, almost 1 meter per second squared larger. So this acceleration is just going to give you a little bit too much force, and it's going to make you airborne as you're going to the top of the amplitude or the crest of the wave here. So I hope you guys found this video helpful, and thank you very much for watching.